Okay, this is actually part 3 video, okay? But I want to start out and I want to remind you, first of all, make sure if you're allowed to use a calculator, it's set in degree mode, right? Again, do that sine 30 equal to 1/2 test like I showed you in the first video, all right? But I also want to make sure you have your unit circle ready to go. Notice at 180, remember 180 would be this way, negative 180 like problem 1, you just go 180 in a clockwise direction. Notice you still get to the same point here. You see the cosine of negative 180 therefore is negative 1 because remember cosine goes with x. If you were asked the sine of negative 180 degrees, then you would say 0, right? Because sine goes with y. So hopefully you kind of remember cosine is x, sine is y on this unit circle. So again, if you look right here, let's test it out one more time. If I want to do the cosine of 60 degrees or pi over 3, I know it's 1/2 because 1/2 is your x coordinate. If I want to know sine of 60 degrees, then I go to 60 degrees or sine of pi over 3. I know it's square root 3 over 2. Now, the other thing I want to ask you is your teacher going to allow you to add extra notes on here, like the tangent of 60 degrees, for example, which is sine over cosine, simplifies to just square root of 3. Are you allowed to do that? If so, I would do that. I would do tangent also on my unit circle, divide the sines by the cosines and make them tangents. So like see the pi over 445, since it's square root 2 over 2 square root 2 over 2, when I divide those, I know that the tangent of 45 degrees is simply 1. So hopefully all that kind of makes sense, but things to think about. Okay, so let's start with number 13 and work our way backwards here. If I want the secant of x, first of all, you ought to know that secant is simply 1 over cosine, right? So there's your answer. You ought to know that cosecant is 1 over sine. You ought to know that cotangent is cosine over sine. And you ought to know that tangent is sine over cosine. So if she's going to test you on things like that, you better make sure you know what you're doing. Okay, now number 12. What about the sine of 7 pi over 6? Again, if you're allowed to use a unit circle, you're going to go here, and the sine is the y coordinate, which is negative 1/2. So you're going to pick A in this case. Okay? So remember, sine is your y coordinate on the unit circle, cosine is your x. Okay, now remember, the arc length formula is really simple if it's in radians. So, for example, on number 11, if they give us the radius and theta is 90 degrees, I would convert this to radians, which is pi over 2. So therefore, the arc length, which we usually call x, is simply r theta, which is 13 times pi over 2, which is 13 pi over 2. So again, the trick to number 11 is if they give you degrees, convert it to radians. Okay? Now, if you forgot how to convert to radians, remember, 90, if I want to convert to radians, I would say that pi I know is 180 degrees. So you would times by pi over 180, right? And you can see that 90 over 180 reduces to 1/2, and that's why it's pi over 2. So hopefully you know this as well. To convert to radians, you times by pi over 180. Okay, the double angle formulas. Are you allowed to have this written down already? Hopefully you're allowed to have this on your cheat sheet, okay? Because if they want the sine of 2 theta, you're going to want to know this. Hopefully you don't have to have it memorized. So I know that the sine of 2 theta is 2 times the sine of theta. Now let's slow down here a little bit. We know the cosine is 3/5. So the first thing I would do actually is I would do a quick sketch. Remember, cosine is adjacent over hypotenuse, right? So if this is my theta, and I'm in the first quadrant, basically always go to the first quadrant for the most part, I notice that my adjacent is 3, my hypotenuse is 5, so I could do Pythagorean theorem and know that's 4, right? Hopefully you know your 3, 4, 5, but, sorry about that, my hand slipped, but if you don't, you're going to maybe have to do Pythagorean theorem. So I know that this missing side here, 3 squared plus missing side squared equals 5 squared. So notice I'm calling this x, of course. So what is going to be x squared is the 5 squared minus the 3 squared. 25 minus 9 is 16. And x, therefore, is the square root of 16, which is 4. But hopefully you know your 3, 4, 5. But now that we know that's 4, we know that the sine of theta is 4 over 5, right? Because this is the opposite, that's the hypotenuse. So remember, cosine is adjacent hypotenuse. Sine will be opposite hypotenuse. And on these problems, you will use Pythagorean theorem if you need to find the missing side. Okay, so long story short, what is sine theta is 4 over 5. What is cosine theta? Oh, I have it backwards, don't I? No, I don't. Is 3 over 5 times 2. So all we have to do is the math here carefully. So 2 times 4, 8 times 3 is 24 over 25. So that's why the answer is B. Okay, so hopefully that helps you a little bit. And that is video part 3.